Have you ever walked past a rock and wondered if it could be hiding gold inside? And what if you could actually melt it down right there to find out? Well, you might be surprised to learn that some rocks can indeed be melted to extract real gold, and ordinary people have been doing this for centuries using surprisingly simple methods. Just last year, a prospector in Nevada found a seemingly worthless chunk of rusty rock near an old mining site, and after crushing and melting it in a basic furnace, he recovered almost 3 ounces of pure gold worth over $5,000. This is not some fantasy or clickbait story, because certain types of rocks naturally concentrate gold in ways that make home extraction possible. And today, we are going to explore 5 specific rocks you can actually melt to recover gold, along with the science behind why it works and how people are doing it safely in their own backyards. Gold does not just appear randomly in rocks, because it forms through very specific geological processes that took millions of years. When hot fluids deep in the Earth's crust move through cracks and fissures, they carry dissolved metals, including gold. And as these fluids cool down, the metals crystallize and get deposited into the surrounding rock. This process is called hydrothermal deposition, and it is responsible for most of the gold deposits we find today. The rocks that form around these gold deposits often have telltale signs, like a rusty red color from iron oxide or a greenish tint from copper minerals, which means experienced prospectors can identify promising rocks just by looking at them. Understanding this process is crucial because it helps you know where to look and what rocks are worth your time. The first rock on our list is quartz, which is probably the most famous gold-bearing rock in the world. Quartz veins run through many mountainous regions, and they often contain visible gold specks or even larger nuggets trapped inside the crystalline structure. The reason quartz and gold go together so well is that they both form under similar temperature and pressure conditions deep underground, so when hydrothermal fluids deposit gold, quartz crystals often grow right alongside it. You can find gold-bearing quartz in places like California, Nevada, Arizona, Alaska, and even parts of the Appalachian Mountains. The quartz itself is made of silicon dioxide, which has a melting point of around 3,200 degrees Fahrenheit, but you do not actually need to melt the quartz to get the gold out. Instead, you crush the quartz into a fine powder, and then you use a process called smelting, where you heat the powder with a flux material like borax in a crucible. The borax lowers the melting point and helps separate the gold from the rocky material. And as the mixture heats up to around 2,000 degrees, the gold melts and sinks to the bottom while the lighter rock material floats on top as slag. People have been doing this in homemade furnaces for generations, and with proper safety equipment like heat-resistant gloves and eye protection, it is entirely feasible for hobbyists. The second rock you should know about is pyrite, which is often called fool's gold because of its shiny metallic appearance. While pyrite itself is iron sulfide and not actually gold, it frequently contains tiny particles of real gold trapped within its crystal structure, and some pyrite deposits are so rich in gold that mining companies specifically target them. This happens because gold and pyrite form under similar conditions, and microscopic gold particles get incorporated into the pyrite as it crystallizes. The tricky part with pyrite is that you cannot just melt it directly, because when you heat iron sulfide, it releases toxic sulfur dioxide gas, which is dangerous to breathe. The proper method involves first roasting the pyrite in open air at around 1,000 degrees Fahrenheit, which converts the iron sulfide into iron oxide and drives off the sulfur as gas. After roasting, you are left with a reddish material that you can then crush and smelt with borax to extract the gold. This two-step process has been used since ancient times, and modern hobbyists still use it today with proper ventilation and safety precautions. Pyrite is found in many locations across North America, including Colorado, Pennsylvania, and Ontario, and some specimens can yield surprising amounts of gold when processed correctly. Our third rock is Chalcopyrite, which is a copper-iron sulfide mineral that often contains significant gold as a byproduct. Chalcopyrite has a brassy yellow color and is the most important ore of copper, but many chalcopyrite deposits also contain gold that was deposited by the same hydrothermal fluids. Mining companies love these deposits because they can extract both copper and gold from the same rock, making it economically valuable. For the home prospector, chalcopyrite requires a similar roasting process to pyrite because you need to drive off the sulfur before smelting. After roasting at high temperature, the remaining material contains copper oxide and iron oxide along with any gold that was present, and when you smelt this mixture with the right flux, the gold separates and can be collected. The copper also melts out, so you might end up with both metals in your final product. Chalcopyrite is commonly found in places like Arizona, Montana, Utah, and British Columbia, often in association with old copper mining districts. The key to success with chalcopyrite is patience, because the roasting process can take several hours, and you need to make sure all the sulfur is gone before you move to the smelting stage. The fourth rock on our list is Arsenopyrite, which is an arsenic iron sulfide mineral that is actually one of the most important gold-bearing minerals in the world. Many major gold deposits contain arsenopyrite because gold particles get locked inside the crystal structure as it forms. The name might sound intimidating, and you should definitely be cautious because heating arsenopyrite releases arsenic compounds which are extremely toxic. However, with proper safety measures, including doing this outdoors with excellent ventilation and wearing a respirator, experienced prospectors do process arsenopyrite to recover gold. The method involves roasting the mineral at high temperature to oxidize the arsenic and iron, which converts them into oxides that can be removed. After roasting, you are left with a material that can be smelted to extract the gold. Arsenopyrite has a silvery metallic appearance and is found in many historic gold mining areas, including South Dakota, North Carolina, and various parts of Canada. Because of the arsenic risk, this is definitely the most advanced rock on our list, and it should only be attempted by people who understand the chemistry and have proper safety equipment. Many hobbyists choose to avoid arsenopyrite altogether and focus on safer options, which is a perfectly reasonable decision. The fifth and final rock is Galena, which is lead sulfide and the primary ore of lead. You might wonder what lead has to do with gold, but the answer is that many Galena deposits contain silver and gold as trace elements. This happens because lead, silver, and gold often occur together in hydrothermal vein systems, and as the Galena crystallizes, it incorporates small amounts of these precious metals. Galena has a distinctive metallic gray color and breaks into perfect cubic shapes, making it easy to identify in the field. To extract gold from Galena, you first roast it to convert the lead sulfide into lead oxide and drive off the sulfur. Then, you smelt the roasted material, and the lead melts at a relatively low temperature of just 621 degrees Fahrenheit. As the lead melts, any gold or silver present will dissolve into the molten lead, and you can then use a process called cupellation to separate the precious metals. Cupellation involves heating the lead in a porous container called a cupel, which absorbs the lead oxide while leaving behind a bead of gold and silver. This technique has been used since Roman times, and it is still practiced by hobbyists today. Galena is found in many places, including Missouri, Idaho, Colorado, and the famous Tri-State Mining District. The main safety concern with Galena is lead poisoning, so you need to work in a well-ventilated area, wash your hands thoroughly after handling it, and never eat or drink in your work area. Now that we have covered the 5 rocks, let us talk about the practical side of actually melting these materials to recover gold. The first thing you need is a proper furnace that can reach temperatures of at least 2,000 degrees Fahrenheit. Many hobbyists build their own furnaces using fire bricks and a propane or natural gas burner, which can be surprisingly affordable and effective. You can find detailed plans online, and some people even use charcoal-fired furnaces similar to ancient bloomeries. The crucible is another critical piece of equipment, and it needs to be made of a material that can withstand extreme heat without cracking. Graphite crucibles are popular because they are durable and transfer heat efficiently, and they come in various sizes depending on how much material you want to process. The flux material, usually borax, is essential because it lowers the melting point of the rocky material and helps the gold separate cleanly. Some people also add a small amount of flour or sugar to the mix, which acts as a reducing agent and helps prevent the gold from oxidizing. Safety cannot be overstated when you are working with molten metal and high temperatures. You absolutely must wear heat-resistant gloves rated for at least 2,000 degrees, and a full face shield is essential to protect against splashes of molten material. Heavy leather clothing and closed-toe boots are also important because a drop of molten metal can cause severe burns. The work area should be outdoors or in a very well-ventilated space, especially if you are roasting sulfide minerals because the fumes are toxic and can cause serious health problems. A respirator rated for metal fumes and sulfur dioxide is a good investment if you plan to do this regularly. You should also have a fire extinguisher nearby and make sure there are no flammable materials in the area. Many experienced smelters recommend practicing with non-gold-bearing rocks first, just to get comfortable with the process and learn how the equipment behaves. The actual smelting process starts with crushing your rock into a fine powder, which increases the surface area and makes the gold easier to extract. You can use a rock crusher or even a heavy hammer at a sturdy container, though a proper ball mill or stamp mill works much better for larger quantities. Once you have your powder, you mix it with flux in roughly a 1-to-1 ratio, though some people use more flux depending on the rock type. You place this mixture in your crucible and put it in the furnace. Then you gradually increase the temperature. As the mixture heats up, you will see it start to glow and eventually melt into a liquid. The gold, being much denser than the rocky material, sinks to the bottom of the crucible, while the slag floats on top. After maintaining the temperature for 20 to 30 minutes to ensure everything is fully melted, you carefully pour the contents into a mold. The slag and gold will separate naturally, and once everything cools down, you can break away the slag and retrieve your gold. The amount of gold you can recover from these rocks varies enormously depending on the deposit and the specific rock you are processing. Some quartz veins might contain visible gold and yield several grams per kilogram of rock, while others might have only trace amounts. Pyrite and Arsenopyrite can be incredibly rich in some locations, with gold content reaching several ounces per ton, but they can also be nearly barren in other areas. This is why prospecting and testing are so important, because you do not want to invest time and energy processing rock that has little to no gold content. Many hobbyists use a method called fire assay testing, where they smelt a small sample of crushed rock to see how much gold it contains before committing to processing a larger batch. This saves a lot of effort and helps you focus on the most promising material. One of the most interesting aspects of melting rocks for gold is the historical connection you feel to ancient metallurgists and prospectors. People have been doing this for thousands of years, from the ancient Egyptians and Romans to the 49ers of the California gold rush. The basic principles have not changed much, though our equipment and safety standards are certainly better. When you hold a button of gold that you extracted yourself from raw rock, there is a sense of accomplishment and connection to the earth that is hard to describe. You realize that this gold was formed deep underground millions of years ago, and you are the first person to free it from its rocky prison. That tangible link to geological history and human ingenuity is part of what makes this hobby so rewarding. Legal considerations are also important to keep in mind, because you cannot just go anywhere and start collecting rocks. In the United States, you need to make sure you have permission to collect rocks from private land, and on public land, there are specific regulations about prospecting and mineral collection. National parks generally prohibit rock collecting, but national forests and Bureau of Land Management lands often allow it with proper permits. Some states have specific laws about small-scale mining and smelting, so it is worth checking your local regulations before you start. The good news is that in most places, small-scale hobby prospecting is perfectly legal as long as you follow the rules and respect the land. The environmental impact of small-scale smelting is relatively minor compared to industrial mining, but you should still take steps to minimize your footprint. Never dump slag or waste materials in streams or natural areas because they can contain heavy metals and other contaminants. Instead, dispose of slag properly or even save it because some people use it for landscaping or art projects. If you are roasting sulfide minerals, make sure the fumes are not blowing toward homes or populated areas, and consider doing it on calm days when the air disperses quickly. Being a responsible prospector means leaving the land in good condition and not creating hazards for wildlife or other people. For those just getting started, the best advice is to begin with quartz because it is the safest and most straightforward option. Look for old mining areas or known gold-bearing regions and search for quartz veins that show signs of mineralization like rusty staining or visible metal. Collect a few samples and try crushing and panning them first to see if you can spot any gold flakes, which will tell you if the material is worth smelting. Join online forums and local prospecting clubs because experienced members are usually happy to share tips and sometimes even good locations. Invest in quality safety equipment before you invest in fancy tools because your health and safety are worth far more than any gold you might find. The science behind why these rocks contain gold is endlessly fascinating, and the more you learn about geology, the better you become at finding productive material. Gold is one of the least reactive elements, which means it does not easily combine with other elements to form compounds. This is why it often occurs as native metal rather than as part of a mineral, though it can be locked inside minerals like pyrite and arsenopyrite as microscopic inclusions. The hydrothermal fluids that deposit gold are typically rich in silica, which is why quartz and gold are such common companions. These fluids move through fault zones and fractures in the Earth's crust, and as they cool or encounter different chemical conditions, the gold precipitates out and gets trapped in the rock. Understanding this helps you recognize favorable geological settings, like areas with quartz veins cutting through volcanic or metamorphic rocks. Some prospectors take their hobby to the next level by learning fire assay techniques, which are the most accurate way to determine gold content in rocks. Fire assay involves carefully weighing a sample, mixing it with precise amounts of flux and lead, and then smelting it under controlled conditions. After cupellation, you are left with a tiny bead of gold and silver that you can weigh to calculate the exact gold content of your original sample. This level of precision requires practice and good equipment, but it is incredibly satisfying to master. Some hobbyists even set up small home laboratories where they can test multiple samples and keep detailed records of different locations and rock types. The tools and techniques for rock crushing have evolved over the years, and modern prospectors have access to equipment that would have amazed the old-timers. Electric rock crushers can reduce large rocks to powder in minutes, and ball mills can grind material to an incredibly fine consistency that maximizes gold recovery. Some people even use metal detectors specifically designed to find gold-bearing rocks, which can save hours of random searching. However, the basic hand tools like a rock hammer, chisel, and gold pan are still essential, and many prospectors enjoy the simplicity and connection to tradition that comes with using manual methods. If you are serious about melting rocks for gold, consider taking a metalworking or foundry class at a local community college or makerspace. These classes teach you the fundamentals of working with high temperatures and molten metal, and they provide hands-on experience in a supervised setting. You will learn proper techniques for heating, pouring, and handling crucibles, and you will gain confidence that translates directly to gold smelting. Many makerspaces also have furnaces and equipment you can use, which lets you try the hobby without investing in your own setup right away. The community of hobby prospectors and smelters is vibrant and welcoming, with people sharing their successes and failures online through videos and forums. Watching experienced smelters work through the process on video can teach you tricks and techniques that are hard to convey in writing, like how to judge temperature by color or how to tell when the smelt is complete. Some prospectors organize group outings where everyone brings their equipment and works together, which is both educational and social. The camaraderie among people who share this unusual hobby is one of its hidden pleasures, and you will find that prospectors are generally generous with their knowledge and eager to help newcomers succeed. We should also mention that not every rock you find will contain enough gold to make smelting worthwhile, and that is perfectly okay. Part of the adventure is in the search and the learning process, and even a smelt that yields only a tiny speck of gold is valuable for the experience it provides. Over time, you will develop an eye for promising rocks and an intuition about which locations are worth exploring. Some prospectors spend years searching before they find a truly rich deposit, but the journey itself is rewarding. Every rock you crack open is a window into the Earth's history, and every smelt is a small experiment in chemistry and metallurgy. The economics of hobby gold smelting are interesting because you are almost never going to get rich doing this. The gold you recover might be worth a few $100s if you are lucky, but the equipment and time investment can easily exceed that. However, most people who do this are not motivated primarily by profit, but rather by the satisfaction of the process and the thrill of discovery. It is similar to fishing or hunting, where the value is in the experience rather than just the end product. That said, there are occasional stories of hobbyists stumbling onto exceptionally rich material and recovering significant amounts of gold, which keeps the dream alive for everyone. As you gain experience, you might start to recognize patterns in the landscape that indicate gold-bearing rocks. Certain types of host rock, like greenstone or schist, are more likely to contain gold-bearing veins. Areas with a history of mining are obvious targets, but sometimes the old-timers missed deposits that you can find with modern knowledge and tools. Stream beds and eroded hillsides can expose fresh rock that has never been prospected, and after heavy rains, new material is constantly being uncovered. The key is to keep your eyes open and never stop learning, because geology is a vast subject and there is always more to discover. For anyone interested in trying this hobby, start by researching the geology of your local area to see if there are known gold deposits or historic mining sites nearby. Visit your state geological survey website, which often has maps and reports about mineral resources. Read books about prospecting and gold geology, and consider joining a prospecting club that organizes field trips and provides mentorship. Invest in basic safety equipment and a small furnace setup, and practice with non-gold-bearing material first. Most importantly, approach this hobby with realistic expectations and a genuine curiosity about rocks and metals, because that mindset will sustain you through the learning curve and make every small success feel meaningful. If you want to take your gold hunting skills even further and learn professional identification techniques that most prospectors never discover, click the Join button below to become a member of our channel. Members get exclusive access to in-depth guides and monthly tests that will sharpen your eye for valuable rocks and help you avoid wasting time on worthless material. Thanks for watching, and do not forget to check out the next video appearing on your screen right now, where we explore even more hidden treasures waiting to be found. Thanks for liking and subscribing. Good luck, Gem Hunter!